In ray optics, we are going to take up the concept of reflection of light on spherical mirrors. In fact, you people all know most of the concepts of spherical mirrors as far as reflection that is concerned, they are all similar even when you talk about refraction taken in the case of lenses. Similarity, not equality. Remember that. And spherical mirrors, while taking up, we used to consider a concave mirror and a convex mirror. This concave mirror is capable of producing both real and virtual images. That is what is called as a convergent mirror. And the second one is convex mirror, which of course is called divergent mirror, and that can only produce virtual images. We cannot get a real image by that. And out of these two, some common features we have to remember. The mirror formula, whatever we take up, is 1 by u plus 1 by v is 1 by f. That's common for both the mirrors and even common for the image, whether it is real or virtual, that is formed by the mirror. But what makes the difference? While taking up or discussing different problems, one should be in a position to write the correct Cartesian convention. New convention what we people used to follow is, in the direction of the incident ray, all the distances are to be taken positive and the distances are to be measured from the pole of the mirror. And opposite to the direction of the incident ray, all the distances are to be taken negative. When you take this particular concept, while discussing about real image formation in the case of a concave mirror, you can understand well object distance u, image distance v, and even focal length, that is f, all the three are taken against the direction of the ray of incidence. So naturally, all the three values are to be taken with a negative sign. Therefore, if you apply that mirror formula for concave mirror, when the image formed over there is real, that can be written as minus 1 by f is equal to minus 1 by u minus 1 by v. In general, we can write that one now as 1 by f is equal to 1 by u plus 1 by v. When you are finding a virtual image formation in the case of same concave mirror, then no doubt f will be taken negative. U also will be taken negative. But the image is going to be formed behind the mirror. In the direction of incident ray, we used to take its distance. Therefore, we take that value of v as positive. So how to write this mirror formula in the case of a concave mirror when the image is formed over there as virtual by nature? Then what is the equation? 1 by u, that's with a negative sign, plus 1 by v is equal to 1 minus 1 by f. That particular convention one should be thorough with while doing different problems based on concave mirror. If you consider convex mirror, never it used to give real images. Always the image formed by convex mirror is virtual by nature. And thereby, what you people used to observe in this case is accepting the object distance. The other two distances are to be taken positive. So what you can write there, minus 1 by u plus 1 by v is equal to 1 by f. That is the way we people used to write by considering new Cartesian system. That is of course a convention what we people used to take. And in addition to this one, magnification or magnifying power of a mirror, when we discuss that one, No doubt magnification m is equal to size of the image by size of the object, which we write generally as h2 by h1. Or you can even write image distance by object distance, that again we people used to write it as v by u. For concave mirror, the image of course may be formed over there smaller than the size of the object, equal to the size of the object, or greater than the size of the object. All the three possibilities we will be finding in the case of a concave mirror. Thereby, magnification may be either less than 1 or is equal to 1 or even may be greater than 1 also. But in this regard, one more point we have to remember as far as the convention that is concerned while writing the magnifying power. The concept is quite simple. If the image formed over there is real, then magnification will be taken negative. That means if the image is formed upside down or inverted, magnification should be written with a negative sign. If the image is formed erect with respect to the object, then we people used to consider that magnifying power or magnification as positive. So what we should understand while writing magnification as far as sign convention that is concerned, the image if it is formed above the principal axis, then the magnification is going to be positive. That is virtual image formation I am talking about with respect to the object. If the image is erect by nature, then magnification will be taken positive. With respect to the object, if the image is formed inverted, upside down, then we people is to take that magnification with a negative sign. And another point to be noted as far as convention that is concerned, all the distances above the principal axis are taken positive. All the distances below the principal axis are to be taken negative. Distance in this particular sense is nothing other than height. Suppose object is placed, that definitely will be placed on the principal axis. In the above, means above the principal axis you will be finding its size. So the size of that object when you consider, that value should be taken positive. And image suppose is formed upside down, that definitely will be below the principal axis, its size will be below the principal axis. In such cases, those distances are heights below the principal axis, we people is to consider that one with a negative sign. So while doing the problem, if you people are perfect and thorough with the conventional signs, whether it is the case of a concave mirror or in the case of a convex mirror, the result of course is going to be perfect. You will definitely be getting the correct answer what is required for that particular problem. Therefore, one should be perfect with this particular convention what we people are following in this topic. If you are perfect with this convention, same convention will be repeated even in the case of lenses as well. The method of taking the convention is same. That time, in the case of refraction of light through lenses, the points are going to be much more easier for all of you to remember. Therefore, let us work out the problems based on these conventional signs, taking them carefully here. I am doing here some of the questions over one after the other rather, and each question I read out, and we are going to discuss the important features related to that, and we shall directly work out each and every number one after the other. Let me just take the very first problem what we people are having. The first problem says an object is placed at a distance x1 from the principal focus of a concave mirror on its principal axis. Object is placed at a certain distance, fine. Usually, object distance and even image distance are measured directly from the pole of the mirror. But in this particular problem, he is giving both the distances from the principal focus of the mirror. So he is talking about an object is placed at a distance x1 from the principal focus of a concave mirror on its principal axis. The image is formed at a distance x2 from the principal focus. The focal length of the mirror is how much? The options are given this way. The first option is x1, x2. Second option is x1 plus x2 by 2, that's average like. Third option is root under x1 by x2. And fourth option is square root of x1 into x2, the product of x1 and x2 under root. That is the fourth option. But the moment you read this one, you can easily get your mind, it is Newton's formula. When the distances to the object as well as the image are taken from the principal focus of the concave mirror as x1 and x2, then the focal length of that mirror f is equal to square root of x1, x2. That is the general formula one should remember. But okay, let us work out even that value also. If I take 1 by u plus 1 by v is equal to 1 by f, because object is real, image also is real like he is talking about. And of course, we know pretty well in this particular case, focal length of that mirror, what has been given, is to be taken negative. When all the three are negative by nature, 1 by f is equal to 1 by u plus 1 by v prevails as it is. So I now can write 1 by u plus 1 by v is equal to 1 by f. That is the mirror formula for us. What are these two distances now to be taken according to the given values? Look at that one. 1 by, I write this one f minus x1. This is 1 by f minus x2. That now is going to be 1 by f. So this is the way we people used to work out by taking u and v according to the given values of x1 and x2. Now if you rewrite the same this way, f minus x2 plus f minus x1 whole divided by f minus x1 into f minus x2 is equal to 1 by f. Now simply cross multiply this equation first. This is already 2f into f, it now becomes 2f square here. Fine. Now minus f x2 minus f x1. That now is going to be f square minus f x2 minus f x1 minus into minus plus x1 x2. Now on both sides minus fx1 you can cancel, minus fx2 you can cancel. Bring this f square this side so that you will be left with f square. It's 2f square minus f square. That now becomes f square. That is equal to x1 x2. What is the focal length of the mirror? That is the question. So f now becomes square root of x1 x2. That is the correct equation. But actually this I have reminded you how to just acquire this result. But in reality this particular concept comes under Newton's formula. If you can remember that Newton's formula directly, it's a very simple concept. Focal length is equal to root of x1 x2 when x1 and x2 are the distances to the object as well as the image from the principal focus of the concave mirror. So this is the equation of course for frequency, this one focal length in terms of object distance and image distance which are measured from the principal focus of the concave mirror. Now this value, this equation in fact is in coincidence with the fourth option provided to us in the problem. So we can write directly the answer for this particular problem as D. So this is the methodology one should remember, and this is the ultimate formula. This also is called as Newton's formula. So remember this one directly as Newton's formula, so that you can avoid this type of calculation in the examination. So this is the first problem what we are having in this order. Check the second number there. A man has a concave shaving mirror of focal length 0.2 meter. How far should the mirror be held from his face in order to give an image of twofold magnification? Twofold magnification, magnification is equal to 2, that is the concept. So you can directly understand in this case, when the object is placed in between the pole and principal focus of a concave mirror, the image thereby formed will be virtual, erect, formed behind the mirror, and important most feature of that image is it is a magnified image. How many times that is going to be magnified in this particular case? He has given magnification is 2, twofold. That means 2 times enlarged image than the object we people are getting in this case. What are the options provided? First option is given 0.1 meter. Second option is given 0.2 meter. Third option is given 0.3 meter. And fourth option is given 0.4 meter. That is the case. Now recollect once again from the concave mirror, what is the general formula for its magnifying power or magnification produced in the case of the concave mirror when the image is formed there? What is that magnification here? Magnification is F by magnification is equal to F by F minus U, I can write. What for you people can definitely understand in this case? 1 by U is 1 by U plus 1 by V is 1 by F, fine. But magnification in this case is mentioning it as 2. So magnification is 2 means V by U is equal to 2. So what we have done in this particular case, magnification general formula is V by U. Then V is equal to M into U. We have substituted that value in that mirror equation and we have simplified the total lot. After doing that, we be getting the magnification in terms of focal length and object distance like this. So what you should understand in this particular case is going to be F by F minus U will now be the correct magnification of that image. What is the focal length given now? Focal length is given 0.2. No doubt 0.2 meter, but it is concave mirror, mind that point. Concave mirror's focal length will always be taken with a negative sign, just because of the convention what we are following. So F will be negative for concave mirror and F always will be taken positive for a convex mirror. So automatically we can write in this case M is going to be 2, no doubt. And F is now should be taken as 0.2 with a negative sign. This also is 0.2 with a negative sign minus U. Now just cross multiply this whole thing please. This is now 0.4 with a negative sign minus 2U is equal to 0.2 with a negative sign. So what can we write now? Minus 2U is equal to 0.4 going that side, 0.4 minus 0.2, it's going to be 0. With what value? Positive value in this case. Now what will be the value of U, the question? It definitely going to be 0.1 meter now. Negative obviously, because object distance always is taken from the pole of the mirror. That according to the convention, we are going against the direction of incident ray. Then automatically the value is to be taken with a negative sign. Of course, the same I have got here. But what is the object distance is the question. At what distance he should hold the mirror? That is the concept. So what can we write now? Distance is equal to 0.1 meter. So at what distance it is supposed to be held so that the magnification becomes twofold? That is the question. So at what distance we have to place the mirror means it should be placed at a distance of 0.1 meter as such. So out of all the 4 options, the very first option is exactly the same value given in the problem. So we can directly take up the correct answer for this problem number 2, that is going to be the first option. So only thing you should recollect directly is m is equal to f by f minus u. When object distance is known to you, focal length is given to you or known to you. So without going for the value of v there, simplified form for magnification is f by f minus u. That is the concept we have to recollect. Okay. So this is the second problem what we are having. Switch over to the problem number 3. A convex mirror has a focal length of 20 centimeter. Underline that wording first of all, convex mirror, it's not concave. So for concave, focal length is to be written with negative sign, and for convex it should be taken with positive sign. Fine. A real object is placed at a distance of 20 centimeter in front of the mirror from the pole. So always object distance, whether it is in convex mirror or in the case of concave mirror, you will be taken negative according to the new convention what we are following. The mirror produces an image at. Where will the image be formed? What is the distance to that image that is formed by convex mirror? In this particular case is the question. And one can directly understand, for a convex mirror, u will be taken with negative sign, v will be taken with positive sign, and even focal length also will be taken with positive sign, excepting the object distance. The other 2 distances are to be taken with positive sign only. Then what can we write now? 1 by u plus 1 by v is equal to 1 by f, the formula. Out of that v will be positive only, f will be positive only, but u should be taken with a negative sign. So that convention is to be taken up a little carefully while writing the mirror formula. Now what are the values he is giving us? Focal length is given 20 centimeter and real object is placed also at a distance of 20 centimeter from the pole of the mirror. So we can directly write this way, it's minus 1 by 20 plus 1 by v is 1 by 20 with positive sign, because focal length will definitely be taken positive for a convex mirror. Now what can we write from this one? 1 by v now becomes 1 by 20 going that side. It now becomes 2 by 20, which now becomes 1 over 10. So directly you can understand that the final image distance v is now going to be simply 10 centimeter. So at what distance the image is formed? That is the question he is asking. The mirror produces an image at what distance? At 10 centimeter we have got. Now check the options given. The very first option is given as infinity. Second option is given 20 centimeter, third one 40 centimeter and fourth one 10 centimeter. Now one should understand first of all why he has mentioned the first option as infinity. By mistake, I have not considered this particular convention carefully. If I write this one 1 by 20 with positive sign, 1 by 20 gets cancelled on both sides. Then 1 by v will be 0. Then v will be 1 by 0. Anything by 0 will automatically be infinity. Therefore, there is a possibility for us to get v at infinite distance like. So the distance to the image is going to be infinity like we may write. without taking the proper conventional sign. So one should be very, very cautious. By any chance, if you are unable to write this conventional sign properly, there is every possibility for you to get V as infinity, and automatically you opt for the first option. But that is not correct, it is wrong, we know that. So be thorough with the conventional sign, that's very, very important. So 10 centimeter he gave in the fourth option. So what we can write directly, the answer for this particular problem is D. That is now 10 centimeter. This is problem number 3, and this convention, be thorough with that one for convex mirror as such. To make you people perfectly acquainted with the convention, what is taken for a convex mirror, we are giving you one more problem almost on the similar lines. Problem number 4. A convex mirror has a focal length f. A real object is placed at a distance f by 2 in front of it from the pole. The mirror produces an image at what distance? So once again you people can understand here, it's a convex mirror. So already we have discussed earlier, for a convex mirror, U will now be taken negative. And we know pretty well, F is going to be positive and image distance also will be taken positive. That is a convention. And what is the thing he is giving you? Focal length f. Real image, that is real object, is placed at a distance f by 3 in front of the mirror from the pole. So you directly can write this way, 1 by u plus 1 by v is 1 by f, that is mirror formula officially. This u now to be taken with a negative sign, the other two will have the same values with the same signs. So what can we write now in this case? This now is 1 by, at what distance the object is placed? It is at a distance f by 2 from the pole he is telling. Therefore, f by 2 take with a negative sign, plus 1 by v is equal to 1 by f. Now you can rewrite the same this way, 1 by v is equal to, this is 1 by f plus 2 by f. Now you can rewrite the same as 3 over f. Then what will be the value of image distance? F by 3. That is the one. So if you just look at those options given, the first option again is given as infinity. Second option is given as f. Third option is given as 2f. And the fourth option is given as f by 3. So what is the correct option now? It should be f by 3 means the correct option must be the fourth one, that is D in this particular case. So this convention as far as convex mirror is concerned, I am repeating once again, U is the only quantity, that is object distance, which will have negative sign according to the convention. The other two like V and F are definitely going to be positive for any convex mirror in any case. That is the point you have to understand. So that is problem number 4. Very commonly asked models as far as spherical mirrors they are concerned, they are the combinations like a concave mirror and a plane mirror combination, or a convex mirror and a concave mirror combination. Like the type of questions are very, very commonly asked models at JEE. So here is one particular model of such kind. This is a combination of convex mirror and a plane mirror. Let me read out the question what he is talking about. A luminous object is placed 20 centimeter from the surface of a convex mirror. Firstly, understand that when convex mirror is the one, we are keeping an object at a distance 20 centimeter from the pole of the mirror. So we can firstly understand this way. This being the convex mirror, this being the principal axis, there is an object somewhere here. Right? The object, of course, you people can take up here as AB. At what distance that object is now placed? At a distance of 20 centimeter from the mirror. He has just given there is an object. Fine. A plane mirror is set so that the virtual images formed in the two mirrors coincide. A plane mirror is now placed in between. In what manner he has placed that one? Try to understand that. The image due to this convex mirror and the image formed by the plane mirror, both are no doubt virtual and both are coinciding with one another. I read out the second sentence once again, try to understand the concept behind. A plane mirror is set so that the virtual images formed in the two mirrors coincide. Now, where he is placing the plane mirror, he has given. If the plane mirror is at a distance of 12 centimeter from the object, plane mirror is at a distance of 12 centimeter from the object, then the focal length of the convex mirror is how much? That is the question. So, where is the plane mirror now located? It is at 12 centimeter from the object. This is the object now. Let us consider this one is going to be the plane mirror. It is at 12 centimeter from the object. That means certainly you will be finding its image is going to be formed somewhere here. This is the image IG. At what distance it will be formed again? Exactly at 12 centimeter you will be getting the image distance, because for a plane mirror, object distance and image distance with respect to the mirror are equal. So, when object is at a distance 12 centimeter before the plane mirror, image also must be formed at the same distance. But you officially know this one is only 8 centimeter. Because total is given 20, this is 12, then automatically this becomes 8. Then what would be the distance to this image formed? Is it not 4 centimeter now? So you can now understand object distance from the convex mirror is 20 centimeter. Observe the wording. This is the object for this mirror, no doubt. It is at a distance of 20 centimeter. He gave, fine. Where is its image formed with respect to the convex mirror? With respect to the convex mirror, image is formed at a distance of 4 centimeter. So you can directly understand V must be 4 centimeter. And what is the focal length is the question. So you can now understand this one directly, that the image formed by this plane mirror and image formed by this convex mirror, both of course are in coincidence with each other. So the image formed by the plane mirror will have the same size. Image formed by the convex mirror will be smaller than the size of the object. Fine. Now U is given, V is given. How much is the value of F is the question. So we can now write it's 1 by U plus 1 by V is 1 by F. Again U should be taken with a negative sign. So what can we write now? 1 by 20 plus 1 by 4 is equal to 1 by F. Now you can take just 20 as LCM here. it's minus 1, this is 5, is equal to 1 over f. Then what is the value over here? This is now, this implies f is going to be 20 by 4, which now becomes 5 centimeter. Look to those options given there. First option is given 10 centimeter. Second option is given 5 centimeter. Third option is given 20 centimeter and fourth option is 40 centimeter. So you can definitely understand in this case the second option is exactly given as the value what we have got. So we can say the correct answer for this one is B. Only thing you should understand in this entire description, once again I will repeat, image formed by the plane mirror and image formed by the convex mirror, both are no doubt virtual and both are coinciding with one another. That is the clue what he is giving us in the problem. So automatically object distance and image distance as far as the plane mirror that is concerned are supposed to be equal. Then this becomes 12, out of that this distance becomes 4, that itself will be the image distance with respect to the convex mirror as such. So this is the method what one has to follow to get the focal length of the given convex mirror as 5 centimeter in this problem 5. Switch over to the next number, that is problem number 6. A concave mirror of focal length 200 centimeter is used to obtain the image of the sun, which subtends an angle of 30 minutes. Then the diameter of the image of the solar disk is how much? The options are given this way. The first option is 12.48 centimeter. Second option 1.75 centimeter, and third option it's 9.87 centimeter, and fourth option is given as 20 centimeter. First and foremost, you should understand in this problem what is the object. Object is the solar disk. Where is it located? Surely we take the distance as infinity. When object is at infinite distance, in the case of a concave mirror, the final image is going to be formed at its focus. I repeat once again, when object is at infinite distance, in the case of a concave mirror, the final image is going to be formed at its focus. It's just like a pointed image, just like a small dot. That's one area we have to understand first. And what is the angle it is subtending? He said, which one is subtending that angle? Image of the sun, which subtends an angle of 30 minutes. So angle subtended by the image, if I just write angle subtended by the image, it is 30 minutes. So you directly can write that one as half a degree. 30 minutes, 30 by 60, it's 1 by 2 degree, fine. But we at the same time know 180 degrees is nothing other than pi radian. Then half a degree, what will be this value? So you can directly write this one half into pi over 180. That is the general way we people used to adopt. Otherwise you can write pi by 360 in this case. This is going to be the total value of theta in radian. Why to write in radian? Generally we know pretty well SI units when we follow. Angle has got radian as its unit. Degree we never used to consider in general. So one should first of all convert the given value in terms of radian first. It's over now. I have made that one ready. So it's pi by 360 radian. That's going to be the value of angle subtended by the image of that solar disk which is formed at the focus of the concave mirror. Fine. What is the thing he is asking? What is the diameter of the image? then the diameter of the image at the solar disk is how much? So what we can understand in this particular case is magnification generally is V by U, we call it. That of course is taken as image, size of the image by size of the object also. So what is his question here? Diameter of the image of the solar disk, what will be that value? That is the concept. What is the focal length given? It's 200 centimeter. So magnifying power V by U now can be written as F by U, because image distance is equivalent to focal length here. So directly we can write now what is the diameter. That now is going to be this angular value into the value of the focal length. 200 centimeter he has given you. So you can cut this one over here. 10 times 2 and 18 times 2, let us take it like this, pi 3.14 into 10 divided by 18. Now you can write 31.4 by 18. That comes to be 2 times 18 means it is 36. It's more than that, but very close to the value of 2. That much we are certain. Therefore, we can say this value will be around 1.75 centimeter. So what is the corresponding diameter he is asking you of the disk? So diameter of the disk, if you consider, it's 1.75 centimeter, which we have got here, and that is in coincidence with the second option provided to us in this problem 6. So we can directly take the answer for this one as B. That is problem number 6 for us. Only thing you should understand from this calculation is, don't consider the value of angle directly either in degrees or in minutes or in seconds like. Convert that one into radian and then you work out. That is the case. This is problem number 6 what we have. Next number is problem number 7, one of the excellent model questions what we have. A ray of light travelling parallel to the principal axis of a concave mirror strikes the mirror at an angle of incidence theta. If radius of curvature of the mirror is capital R, then after reflection, the ray meets the principal axis at a distance x from the center of curvature. Then x is equal to how much? One of the excellent questions. And of course 90% of you people may even take the first option for granted in this case, and that is not a correct option, what for we shall discuss now. Let me explain you what he is talking about by drawing a small figure here. He is talking about a concave mirror. If you consider this is a concave mirror what we are having. The outer surface is completely silvered, and this one is the principal axis. You can certainly understand even that point as well. Now according to him, a ray which is falling parallel now is passing through a point like this on the principal axis. And if you take for example a normal that is drawn here at this point of incidence, certainly that normal passes through the point called center of curvature. Generally what is our calculation? Look at, when this is incident ray, this is reflected ray, every time we feel any ray which is falling parallel to the principal axis, that should pass through the point called focus like we think of. But that is not correct always. What is the condition for its correctness? Simple. If the aperture of that mirror is very small, then only the point through which the reflected ray is passing, that should become the focus. And what is he talking? It's just striking at an angle of incidence theta, then automatically angle of reflection also will be theta. And you can understand well, if I name this point as, this one as A, this one as B, this one as D, right? When ABC is angle theta, the angle over here also will be theta. And this angle is theta, this angle is theta out of this particular triangle BCD. Then what will be this angle now? It is pi minus 2 theta. And what else he is talking about? He is just giving us this distance as x. Observe this point carefully. CD distance is given as x for us. Distance between C and D is given as x. Suppose if you do not know this proper condition, what is that condition I have repeated just now? Unless the aperture of the mirror is very small, the ray which is reflecting after falling parallel to the principal axis need not pass through the point called focus. So this point, had it been the focus, you should have given x is equal to simply f. And you can understand well f is equal to r by 2. But in this particular case, that is not correct. Therefore, x is not going to be r by 2. So first option you will not be having a correct there. So what is the other option we people have to look into? Now take this triangle, that is BCD triangle, and analyze the triangle here. X by sine theta. And this distance is known to as r, can be equated to r by sine pi minus 2 theta. Observe this concept carefully from this triangle. X by sine theta is r by sine of pi minus 2 theta is equal to this distance by sine theta also we can write. What is the distance we do not know, therefore I am not attempting that value here. When you equate these two, can't you just write x by sine theta now it becomes r by sine 180 minus 2 theta, that again will be sine 2 theta. So what can we write now? X by sine theta is equal to r by 2 sine theta cos theta. That is the value. Out of that, sine theta gets cancelled. Then what is now left over? X must be r by 2 cos theta. That is the relation between r and x what we people are getting. If you consider this x is equal to r by 2 cos theta, that only he is asking you what is x in terms of r. See the first option given, it's r by 2. See the second option given, r by 2 tan theta. Third option, r by 2 cos theta. And fourth option, r by 2 sin theta. So out of the four options, it is exactly the third option what has been provided to us in the problem. So r by 2 cos theta. So you can say the correct answer for this one is C. But check once again. If cos theta becomes 1, observe that wording, if cos theta becomes 1, then only you will be getting x is equal to r by 2. That means what you can understand there, unless the aperture is small, this distance is not going to be equal to the focal length, remember that condition. Therefore, one has got every possibility to be confused here. Looking to the first option, immediately you may put that one as r by 2, but that is not correct. unless that fellow says in the problem that the aperture of that particular concave mirror is to be taken very small, you should not consider the first option, then automatically the option will be the third one if you analyze it in this manner. So, one of the good questions we have here, and one question which of course can confuse you directly with the first option what has been given there. So, be thorough with that one, be careful about the aperture of that concave mirror, and then finalize the correct answer like this, which is r by 2 cos theta, that is tallied with third option here for the problem number 7 for us. Check the next number now, that is problem number 8 for us. An object is placed at a distance of 2f from a concave mirror of focal length f. So, the moment you read this first sentence, you can directly get to your mind, object is now placed at center of curvature of the mirror. When focal length is f, 2f distance means that is the distance to the center of curvature, which is called radius of curvature. So, you are placing the object at the center of curvature of that concave mirror. The moment you place an object at the center of curvature, how the image will be formed we all know. You will be finding a real image, inverted by nature, having the same size of the object, which will be formed at the center of curvature only. That means whenever object is at the center of curvature, image also will be formed at the same center of curvature of that concave mirror. That is the first point you should understand from the first sentence given in the problem. Let us continue the rest. Light reflected from the mirror falls on a plane mirror. That means this time also a concave mirror and a plane mirror combination he is taking. Where is the mirror placed and all? Of course, he is telling now. The distance of the plane mirror from the concave mirror is f. The distance of the final image due to reflection at both concave and plane mirrors from the concave mirror is how much? So, he is talking about after the reflection is taking place on both the mirrors, the final image is going to be formed somewhere. Where is that final image formed and what is the distance to that final image from the concave mirror? That is the question he is asking. So, where the final image is formed with respect to the concave mirror, not with respect to the plane mirror he is asking. So, the options are given this way. First option is given as f. Second option is given as f by 2. Third one is given as 2f and fourth option is given as 0. Let us first of all draw a figure for the image formation in the case of this combination of concave mirror and plane mirror respectively. Let us start this way. This is a concave mirror now for us. This one is the principal axis of it. If I consider this is its focus, then automatically this will be the center of curvature, because center of curvature is at a distance twice the distance of the focal length. That of course we all know it very well. And this is the point what we call it as pole of the mirror. Now his question is, an object is now placed at the center of curvature. This I take it as AB, and this is the point called center of curvature. Where do you find its image now? Image will also be formed at the same point, right? And this image I write it as IG. The image, the features of the image we all know. It's real, inverted with respect to the object, formed at the same point and having the same size as that of the object. So, the sizes are also equal, distances are also equal, everything same, like we can understand fine. But what is he giving now? A plane mirror is placed at a distance f from the concave mirror. That means the plane mirror is here. This is the one what we people are getting. At what distance it is being placed? At a distance f it is being placed. So first and foremost, if you take alone this concave mirror, you can finalize half the problem. Look at object distance is 2f. You can certainly understand from the figure, object is placed at a distance 2f. Then image also will be formed at the same distance, that is 2f again. So the distance always is to be measured with respect to the pole of the mirror. That's why we people used to extend this arrow a little like this. Fine. Now this is actually 2f, this is 2f, this is object distance, this is image distance. Fine. Now we are placing a plane mirror. Where are we keeping that? Right in the middle. So that this distance is f means this distance also will be f only. Now observe carefully, the real image formed by the concave mirror will now becomes an object for this one. I am repeating once again, the real image formed by the concave mirror that now becomes an object for this plane mirror. So where will its image be formed now? At the same distance on the other side it will be formed. The image will definitely be formed on the concave mirror now. And what is his question? The distance of the final image due to the reflection at both concave and plane mirrors. The ray whatever is falling here will now be reflected from here. And the final image will be formed at what distance? At a distance f. So when object is at a distance f for this, image also will be formed at the same distance f. And what is this object here? Virtual object. Then we will be getting a real image there on the other side. Fine. At what distance? At a distance f. That means where the image will be formed. So what we can understand in this case is final image will be formed on the concave mirror. On the concave mirror. Therefore, distance to the image, distance to the final image from the mirror, from which mirror? Concave mirror. That's what he is asking. Distance to the final image from the concave mirror must be 0. It is rightly formed on the mirror. When the final image is rightly formed on the mirror itself, from pole to the same pole, there is no distance gap between those 2 points, what we are talking them as pole over there. So we can understand here the image will be formed right on the concave mirror again. Thereby the distance to that final image from the concave mirror will automatically be 0. So out of all the 4 options given, you check once again. First option is given as f. Second option is given as f by 2. Third option is given 2f and fourth option is given as 0. So what is the correct option for us? It is 0, that is correct option, which of course is tallying with the fourth option given in the problem. So only thing you should understand is the real image formed by the concave mirror becomes a virtual object for it. Then automatically we will be getting its image somewhere on the mirror now. That is the one what we have to consider. So this is problem number 8, whatever we people are having. Check the problem number 9 now. A concave mirror is placed on a horizontal table with its axis directed vertically upwards. concave mirror is now placed like this on a flat table. This is its axis. Axis is vertically up, that is what he is talking. Let O be the pole of the mirror and C its center of curvature. So, what exactly is describing? Let me just show you here. There is a concave mirror which is placed on a flat table like this. This is O he is talking, and of course, this is going to be the axis of this mirror. And you can say this is the point called C, which is the center of curvature of that concave mirror what he is talking about. So, you can now say this is a silvered surface, right, and it is a concave mirror. This is a pole, that is center of curvature, which is placed on a flat table, that is the one. A point object is placed at C. It has a real image also located at C. Obviously, when an object is placed at center of curvature, its image also will be formed at the same center of curvature, we know that point well. If the mirror is now filled with water, the image will be, that is the concept actually what he is asking for. And he has given us 4 options. The image will be real and will remain at C only, that is the first option. The image will be real and located at a point between C and infinity. And third option, the image will be virtual and located at a point between C and O, somewhere in between these two, that is what he means. And come to the fourth option, the image will be real and located at a point between C and O. It is a real image we are going to get, and the distance between, the position of course of the image will be lying in between C and O, that is the fourth option given. First and foremost, if you look at this figure, when object is placed at C, image also will be formed at C only. Till that extent it is fine. But now what is he doing? He has just filled this mirror with water. This is what actually is now explaining in the figure. Whatever the problem he has mentioned, I am just showing you in the case of this figure, please. It is now filled with water. Then what happens? A ray, whenever it is falling from the object, that first should cross this water lens, which is plano-convex by nature. So, firstly the image, that ray should cross this water lens. It now falls on the concave mirror, then reflects. After reflection, again the ray should pass through the same water lens. That means what will you get? The ray, whatever is incident now, has to pass through that water lens twice, and it reflects at the concave mirror once. So, taking this particular concept, can't you just estimate what would be the effective focal length of the system now? In fact, we all know when lenses are combined, are joined one with the other, 1 by effective focal length is equal to 1 by f1 plus 1 by f2 plus 1 by f3, like that we people used to write. Same concept is to be taken even in this case also. Look at how to calculate the effective focal length. 1 by effective focal length, firstly is 1 by focal length of water lens. Observe carefully. Plus 1 by focal length of concave mirror. plus again 1 by focal length of water lens. That means I can write this one twice. So how many times it is passing through the water lens, please? 2 times. Once while entering it has to pass through the water lens. Once while leaving it has to pass through the water lens. In between it is striking the concave mirror and reflecting back. So to calculate the effective focal length, we have to take all the 3 into consideration and we should write the formula like this. And all of you know, for a plano-convex lens, 1 by f is equal to mu minus 1 by r. According to lens maker's formula, what we people have taken up there. So how to write this one now? 1 by f effective is equal to twice mu minus 1 by r. Mu, if I take, that is the refractive index of that water, which of course the medium over there considered, then twice mu minus 1 by r, that will be this value, plus 1 by focal length of the concave mirror. In fact, all of us we know radius of curvature, if I take it as r, focal length will be r by 2. And in this particular case, this distance is given as r only. You can all understand that is radius of curvature. So how to write the focal length now? 1 by r by 2, that now becomes 2 by r. So what will be this result now? If I take 2 by r common, this now becomes mu minus 1 plus 1, then this gets cancelled. So what is now left over? 2 mu by r, that is the value what we are getting as far as 1 by f, that is reciprocal of focal length of the system that is concerned. Then what I can write from this one? Focal length effective value now becomes r by 2 mu. So the effective focal length, we people are getting r by 2 mu. Now just to decide your answer, taking this value. When f is equal to r by 2 mu, you can understand mu value for water, if I take, it's around 4 by 3. So you can directly write 4 by 3 means 1.33. Twice 1.33 when we write, is it not 2.66? So certainly the moment this value, earlier f was r by 2 only, now f is becoming r by 2 mu. So certainly the present focal length of the system is less than the focal length of the system earlier. Earlier in the sense what? Before putting water into it, whatever was the focal length we were finding, when comparing to that focal length, this value of focal length will definitely be less now. So what you can understand when focal length is less? Obviously, the image should be formed at 2f. 2f corresponding to this value. 2f corresponding to this value means what? Definitely the distance once again be reduced. So the image will definitely be formed as real, and it will be located where? In between C and O. So what is your conclusion here? Since I write the value, since f is less than the focal length of concave mirror, image will be formed at 2f, which will be less than twice f of earlier. This 2f must now be less than twice f of earlier. And it is what kind of an image? Certainly the image is real. When it is real image, when it is formed between the earlier distance to O from this particular point, like this is the object what we people are taking up, this is the image what we people are considering, this is the pole what we have considered, everything is okay. But earlier distance from this point to this point, now present distance are different. Present distance is less than the earlier one. Therefore, which one you can adopt out of the 4 options given? First option, if you look at real and will remain at C, no chance. The image will definitely be less than that point. Or that means the distance between these two will not be this much. It will be less than it. So, the first option is not correct. Second option you look at, real and located at a point between C and infinity. This is C, infinity somewhere. That means image should be formed beyond C. That's not possible. I have already told you it should be well within C. So, second option is not correct. Third option, you need not go for it at all. Reason, he is talking virtual image formation. But we are going to get real image formation here. There is no question of virtuality. So, third option is wrong. Then pick up the right one. Fourth option must be the correct option now. The image should be real and it should be located at a point between C and O. Definitely the correct option, that means image lies between C and O. Therefore, the correct option for this one is going to be D for us. So, first thing what you need to do in this type of a problem is calculate the effective focal length of the system. The moment you people have got effective focal length there, automatically you can expect where the final image that is going to be formed. Because when f is less than original value, 2f also will be less than original value. So, no chance for the image to cross that point C. It will definitely be well within that point C only. So, our answer must be the fourth option, which of course gives you that the image will definitely be formed between O and C only, but that image is supposed to be real, because convex lens in this particular case, when object is at a distance 2f, will never form a virtual image. So, we can definitely understand that concept. It should be a real image and the correct answer is supposed to be D for us in this problem number 9. Check the next number, that is problem number 10. A cube of side 2 meter is placed in front of a concave mirror of focal length 1 meter with its face A at a distance of 3 meter and face B at a distance of 5 meter from the mirror. Once again he is talking about a concave mirror and a cube is placed from that one he is talking. At what distances the nearest side of the cube and the farthest side of the cube are located? He has given one at 3 meter from the face of the mirror and one at 5 meter from the pole of the mirror as such. The distance between the images of face A and B, that is one value he is asking, and heights of images of A and B are respectively how much? Let me just draw a small figure to make you understand what he is talking about in this particular problem. This is the concave mirror, what he is talking. This is its principal axis, that also we know well. And he said the focal length is 1 meter. And when focal length is 1 meter, this is f we can write, and this one is center of curvature we can write. This is given 1 meter and automatically this total distance becomes 2 meters, fine. But what is he giving? He is placing this time not a linear object like a solid piece, a cube he is placing. At what distance he has placed that one, you just observe this one first. He has placed a cube here. This one is the cube what he is talking. If I take this face as A, this face as B, what is he giving you? First of all, 2 meter is going to be the side length of the cube. Side length is 2 meter, fine. Where is that first face located from the pole of the mirror? He said it is at a distance 3 meter like this. The first face of the cube is now located at a distance 3 meter from the mirror. That's the first thing what he has mentioned. Since this side is going to be 2 meter, the distance to the second face of the mirror, second face of the cube, that will now be 5 meter as such. So, from here to that distance is given 3 meter, from here to this distance is given 5 meter, focal length is given a meter, and of course distance to the center of curvature automatically will be 2 meters, fine. Now what are the things he is asking us to calculate? Look at the first one. Distance between the images of face A and face B. So we have to calculate two distances separately now. What is the first value? Look at here, I just calculate for A. The first face A I am talking about. What are the values known to us? Object distance is given 3 meter. Focal length is given 1 meter. And we just want what will be the image distance now. That I write V1. Or I can write even VA. That is image distance from the mirror of the image of A that is formed. So what is the way we people used to go for? The equation of course is known to you. 1 by U plus 1 by V is 1 by F. Now we can write this way, 1 by minus U. Right, minus 1 by V. Right, or plus 1 by V is equal to 1 by F. That focal length of that mirror that has been mentioned. We know according to mirror formula, 1 by U plus 1 by V is equal to 1 by F. I now write this one, 1 by VA is 1 by F minus 1 by U. But we know pretty well F is given 1 and U is given 3, but we have to write this is minus 1 by 1. And this one is to be taken minus 3, minus of minus, that now becomes plus 1 by 3. So what is it you are going to get from this? It's minus 1 plus 1 by 3. Minus 3 plus 1, it's minus 2 by 3. So what will now be the value of VA? It's minus 3 by 2. What? Meter. So that is the first distance to the image of the part A formed by the concave mirror. Probably you might have followed this point. Minus 3 by 2 meter we people are getting there. Now let us write the same calculation for B now. What is the distance to this object given? 5 meter. Focal length again 1 meter. What is the image distance is the question. Image distance of the second face, that is B, that's what we want. Now once again I will just write the same formula. 1 by VB is equal to 1 by F minus 1 by U. Now let us write the values once again given here. It's minus 1 plus 1 by 5. Minus 5 plus 1, it's minus 4 by 5. So what will now be the value of VB? 5 by 4 with a negative sign, so many meter. So both the values of image distances of A and B, I have got them. Now you can understand what is the first bit he is asking. Distance between the images of face A and face B. So you can definitely understand the first bit. What is VA minus VB? That is the question he is asking. What is VA minus VB? VA is minus 3 by 2. VB is minus 5 by 4. Minus of minus now becomes plus 5 by 4. What will be the value now? It's minus 6 plus 5 by 4. That is now minus 1 by 4, which now is 0.25 meter with a negative sign. So observe carefully, what is VA minus VB is my first calculation. What is its value I have got? Minus 0.25 meter. In reality, after completing the first part of the calculation, you need not work out the other two according to this problem. What is the reason? You just look at those 4 options given. First option he said 1 meter, 0.5 meter and 0.25 meter. What is the order he is giving? 1 meter is the distance between the images. 0.5 meter is magnification of the first side and 0.25 is magnification of the second side of the cube. In the same order, he gave the second option 0.5 meter, 1 meter and 0.25 meter. Third option 0.5 meter, 0.25 meter and 1 meter. And see the fourth option 0.25 meter, 1 meter and 0.5 meter. Automatically first option is tallied, this value is tallied with the fourth option there. So straight away you can take the fourth option, but only I have calculated one value out of the 3. Let us work out the other 2 also. What is the next question he is asking? Height of images of A and B. Height of the image we just want. So you can directly write the second one. Look at first. Height of the image A I want. Height of the image by height of the object is equal to V by U is equal to magnification. There is a formula like that. All of you are familiar with this formula. Magnification is equal to height of image by height of object, which of course can even be written as image distance by object distance. We know that formula very well. Same you apply, height of the image is equal to V by U into H of object. Same thing you take, height of A is equal to VA by U into 2 meter. Why 2 meter? That is size of the object. Its side is given 2 meter for us. We know that value very well. Now what is VA? Look at this. It's minus 3 by 2 into 2 by what is object distance he has given? 3 meter for A. So you can write 3. So 2 cancels, 3 cancels and you are left with 1 meter. So what is going to be the height of the image of A that is formed there? It's 1 meter. And height of course is a negative 1. Why? When can we take negative? You all know very well. When the image distance or the size, if you measure above the principal axis, the value should be taken negative. Above the principal axis, all heights are taken positive, and below the principal axis, we should take negative. It is a real image here. Definitely, it will be below the principal axis. It should be taken negative. Fine. What next I want? The third, a very, very simple concept again. This time, height of B I want. How do we write once again in the same manner? It is VB by U into 2. What is the value of VB we have got? We all know the calculated value is 5 by 4 minus 5 by 4 into 2 divided by what is the distance to this B? It is given 5. So 5 cancels, 2 goes in 4 twice, then automatically minus 1 by 2, that is minus 0.5 meter you will be getting. Just look at 0.25 meter with negative sign, 1 meter with negative sign, 0.5 meter with negative sign. These are the three values what we have got after calculating. Now all the three values are exactly given in the same manner in the fourth option for us. But negative sign has not been mentioned. He just has given the value straight away. What is the first option? The fourth option, the first part given, 0.25 meter. Second part of that one given, 1 meter. Third part of that one given, 0.5 meter. All the three in the same order we people are getting there. So the correct answer for this particular question is going to be D now. So if you can understand the construction, what we have taken here, where the object is placed, at what distance this face is located from the pole, at what distance this face is located from the pole, like that if you can identify the values carefully, doing such type of a problem is not a tough task. But one should understand a little carefully at what distance the face A is located, at what distance face B is located. All the values we should have perfectly in our mind after reading the problem. So this is problem number 10 what we have, of which the correct option is the fourth one, which is D.